Okay, and that recording will just share with the participants so that anybody can catch up who's got lab work or family responsibilities. And today we'll go into essentially talking about the GPlates models, the rotations, how that's actually encoded, what those plate IDs mean in a little bit more detail. That will then lead us to looking at rasters and raster reconstructions. And as I mentioned, GPlates is incredibly efficient at rotating rasters. Thanks to our amazing lead developer, John Cannon, who's from the gaming industry, video gaming industry. Okay, so today I want to just actually spend a minute just to highlight, okay, we've got AuScope who funds all this research, but then we have this a great community of people who have supported this workshop. So just a brief shout out to, well, at Sydney here, everyone here is involved in GPlates development. Also a few people at Caltech who contribute to development, so Mike Gurnis and the team. But I wanted to, give a great shout out to the amazing communities that support research. So for example, AUGEN, the Australasian Geoscience Educators Network, and I'll show you their website. WMISA, I think that's Women in Earth Science Association. I keep forgetting all the acronyms. There's ANZIC as well here. Oh, conveniently, it's spelled out here. So it's the Australian New Zealand IODP Consortium and the Geological Society of Australia. So I will paste some of those links because I think it's worth you checking them out. So yeah, so here it is. Women in Earth Environmental Science in Australasia, a great network. They organize a lot of wonderful seminars and talks and sessions, writing sessions and mentoring sessions. So really, really worth supporting. And, I'm a member. I'm not a woman. I don't identify as a woman, but everybody is welcome. It's a very inclusive community. So I'm going to put this in the chat. Please support, join their mailing list and get lots of updates. So with me, so fantastic. The AUGEN team is led by Associate Professor Sandra McLaren at Melbourne. And she does an amazing job of herding all these academic cats, all of us across Australasia, to discuss best practices in education. And so I'm really excited. Hopefully with Sandra and team, we'll get to discuss. This is our latest 3D printed Triceratops that I just picked up this morning. So very exciting. So join AUGEN as well. I'm going to drop that in the chat. Okay. ANZIC is a wonderful community. And if you're in a different part of the world, you might have an equivalent that is looking at the ocean discovery program. And so I'll put that up on here in the chat as well. The Geological Society of Australia, again, a great community. So join wherever you are. You might have your local community of geoscientists. So that's really, I wanted to say that none of this is possible without all of these wonderful communities. And just to mention and emphasize that GPlates is a community resource. All the models that we, for example, build, we've released for free, open access, open source for anyone to use and modify. GPlates itself, if you're really savvy with the coding, you can implement things in the source code, and we'd welcome any contributors as well. And lots of people around the world have also been sharing their own variants of the GPlates reconstruction. So it's been really fun to see what everyone's up to. And just on that, fun things, we even made a reconstruction of Westeros, from Game of Thrones. So, if you wanted to chat about that at some stage, remind me. Okay, so before we start, I do want to acknowledge the traditional owners on the land from which I'm broadcasting. I'm lucky to be on Gdal country, and I pay my respects to the elders past, present, and emerging from the Eora Nation, and recognize that this has been a place of learning and knowledge exchange for, you know, tens of thousands of years, probably back to 100,000 years ago. And again, just a brief mention of AuScope. Thank them for the funding. Today you'll be putting up with us, and I just wanted to give a special shout out to Jono. Jono is in here helping with various technical questions. So thanks, Jono. Okay, so let's get into it. So yesterday we were talking about relative plate motions, how we constrain those, and this is just a visualization in GPlates. You can see the seafloor spreading isochrons. You'll see some of these fracture zones that highlight the direction of motion, and you see these plate topologies, which we'll talk a lot more about later on. This morning, one of the first things we'll talk about is, you know, how do we actually define rotations, just so you get a bit more comfortable with how GPlates does it. It's not some black, you know, dark arts in the background with that you can't change. You know, these are rotation files that have plain text that can be edited or interactively modified in GPlates itself. And we talked a little bit yesterday about absolute reference frames. So, you know, before we were just showing Antarctica fixed, and here I'm showing what happens if you have the hotspot reference frame as well as the relative plate motions. Okay, so we'll talk a little bit about the kinematics, you know, the plate velocities and speeds, and how you can extract those. And a lot of people find that quite useful for teaching, but also their research as well. Okay, so yesterday we started talking about the static polygons and plate IDs, and I just wanted to rehash that a little bit. So the best example of all of this is if we just look at those static polygons that you can, I mean, you can load them into ArcGIS or QGIS and interrogate them, and you'll see that there are these different, you know, regions, different colors, and they are represented by the plate ID. The plate IDs are integer values. Okay, they're an identity for some tectonic element, and so GPlates will apply a common rotation, you know, the same rotation to anything that has the same plate ID. So for example, North America here is 101. Okay, so that motion is set out in the rotation file. Okay, I'll just there's a little bit of audio feedback, so I think I'll
yeah, I'm just muting a few yeah, people that have forgotten to put mute on. So it should be
that's
good.
okay. Yeah, but feel free to unmute and shout out and interrupt me and ask me questions. And Jono, particularly if I've forgotten to explain anything. Great. Okay. And so yeah, so we have plate ID. So, you know, North America 101, South Africa 701, and so on, right? And one of the things just to remember is that the spin axis is a special plate ID, it's 0. And we've inherited the standard from the old plates format, which has a special plate ID reserved for comments in the rotation file. And you might come across that when we open the rotation file, and that's a 999. Okay, so practically all of the numbers are game, you know, integers are game. You can use, check for, you know, plate ID use, but 999 is a special one, and it's a commented out line, and GPlates will ignore those lines in the rotation file. So just be aware of that. Okay, now, so we've got these geometries, and as I mentioned yesterday, they are stored in present day coordinates. So whether it's your fossils or your, you know, igneous rocks or whatever you've got, they are stored in their present day coordinates. GPlates is smart enough that, you know, for example, you can digitize, you know, some volcanic arc, you know, 100 million years ago on that reconstruction, and assuming that you give it a plate ID, you attach it to say North America or whatever. GPlates will then rotate that to its present day coordinates. Okay, so that's kind of the standard way that GPlates stores geometry. Okay, now to move these geometries around, it uses what we call the rotation model, or a rotation file, and it's just a plain text file with a number of columns, and we'll talk a little bit about that. This is just a close-up of those static polygons. I won't dwell on it. But this is what a rotation file typically looks like. Okay, and I'll just briefly explain what the columns mean. So the first column is the plate ID. You see it's an integer value. Okay, so it's the plate ID. You can add your own plate IDs. You just have to make sure that you don't introduce conflicts. So for example, if there is an existing plate ID of 721, well, you should try to find a spare plate ID, 722 maybe. Looks like it's free if you're wanting to introduce a new tectonic element. Okay, so first column is the plate ID. The second column is the age in MA, so millions of years ago. Okay, so you can see that here. And then we have the Euler rotation. So this is what mathematically describes the motion of any geometry on the surface
Ich bin
of a
irgendwie in
sphere.
letzter Zeit spät, egal was ich mache.
Okay, yeah, so these are the finite rotations. If anyone wants me to explain these things in a little bit more detail, because there is a difference between finite and stage rotations, but essentially these are the instructions for GPlates to move things around. So there's a pole of rotation, so coordinate, and then the magnitude of rotation is just the angle. Okay, and the finite rotation just means it's at 65 million years ago. It's the total rotation from 0 to 65 million years ago. If I go to 79 million years ago, again, this is a total rotation, a finite rotation, to get any geometry from present day to this time. And so GPlates uses this kind of cascading method and interpolates at any time these positions with respect. So there's your tectonic element, some part of Africa, I assume, and the relative plate ID, the conjugate plate ID, 701 in this case. Okay, so this then gives you an idea of what the plate motion hierarchy is like. Okay, so 750 moves relative to 701, and then 701 moves relative to the hotspot reference frame, and that has typically a plate ID of 001, and then the spin axis is 0. Okay, and you can see this is what we call a plate motion hierarchy. And so Mohammed, I think asks a little bit about the bit more detailed explanation. I'm happy to just quickly explain. So essentially these are, like I said, the total finite rotations, but between these times is what we call the stage rotations. Okay, now GPlates does have a little tool that helps you convert stage rotations and add them up and turn them into finite rotations. Okay, yeah, so Chris asks about the sign assignment for the rotation angle. Yeah, that's a very good question. So essentially the way it works is that if you have the pole of rotation, okay, so that's this coordinate, and then you have an angle which is positive or negative. Now positive means clockwise rotation about that pole, and negative is counterclockwise. Okay, and that's with respect to a fixed anchor plate. So you can play around with that a little bit if you say anchor 802, which is Antarctica, and see what Australia is doing. Okay, so hopefully that explains it a little bit. And in GPlates, as I mentioned, you can select these tectonic elements and modify their positions on the fly. So you choose your reconstruction time, and you can click and drag and reorient these things, and click apply to set that position. I can demonstrate that a little bit later as well. Keep in mind, so here's a little trick. Here's a little tip from I guess years of having to deal with this. So For example, if you might not be able to see, hopefully you can see, but this is Australia at 801. Sorry, Australia, plate ID of 801 at 10.9 million years ago. So it's reading an existing rotation. Now, if you reconstruct it 10 million years ago and then modify the position of Australia, you're likely to put in a velocity artifact between 10 and 10.9 million years ago if you have dramatic changes. Now, what you can do instead is like you can reconstruct in GPlates to 10.9 million years ago, and GPlates will then overwrite this Euler rotation rather than inserting a new one. So keep that in mind. And I think in most cases, if you modify one of these rotations interactively, GPlates will, in the rotation file, write something like calculated interactively in GPlates, just to let you know that it's been modified like that. And as I mentioned, if you really, one thing you can do is you can comment out a whole bunch of these lines by changing the plate ID to 999. Okay, and then that's important. Now, again, another trick is that you make these edits to the rotation file. Say you might want to do it manually by commenting out this stuff in a text file. You save that change. You just need to make sure that you reload it in GPlates, because GPlates is not aware that you've in the meantime made edits. Okay, so just keep that in mind. So just to give some people an idea of what these Euler rotations, what they might look like. So geometrically speaking, what you can do is you can just draw these, great circles normal to the transforms, okay, at these spreading centers, and they roughly coincide somewhere, and that highlights essentially where the polar rotation of that plate is. Keeping in mind that yeah, the transforms highlight the direction of motion. And here's another example of a rotation file entry. Yeah, and there's the axis of rotation. That's the polar rotation that I mentioned, and then the angle it captures that magnitude of rotation. And Mohammed, yes, it can be done within GPlates, so you can interactively move things in GPlates. But this is kind of just a little bit of theory, and because I'll share these slides with all of you, this might be useful for your own teaching and training of others. Okay, so this is just another example. There's a polar rotation. The fracture zones and transforms are essentially these small circles, and then the ridge segments, if you extrapolated that great circle, they would all essentially coincide on the polar rotation. And just to reiterate that in GPlates, the relative rotations are always between two plates, so plate 1 and plate 2. Okay, and that's how we end up with a hierarchy. Plate 2 might move with respect to plate 3, and so on. I'm not going to dwell on this. There's a really nice animation on this process. Okay, so just to give you an idea of what the Euler rotations are, and I just want to highlight that you've got the Euler pole, the polar rotation, and really speed there is 0. It's just purely rotational. There's no lateral movement of the plate, but you've got other things like the Euler equator, and that's where your speed is much greater on these tectonic plates. So if you have a very large tectonic plate like the Pacific, it depends where the polar rotation is, will determine the gradient of velocities across that plate. Okay, and so essentially when you get these rotations together in the rotation file, which I'll show you in a moment, you can describe the motion of all these tectonic elements on the surface of a sphere. So I'll just very quickly jump in and show you where you can see that. So if I go to Applications, GPlates 2.3, Geodata, feature collections, and then, yeah, for example, here's the rotations in here. Here's just an example rotation file. And I'll just turn off word wrap so you can see. Okay, so there's the age, plate ID, age, pole of rotation, and the angle of rotation, the relative plate ID, and some comment. Okay, so you can make edits to this manually when you get to a little bit more confident, or you can make those edits in GPlates. Now, what I'll do is I'll just demonstrate this, and I'll make a copy of this rotation file. Okay, we can just call it test. Whoops, test.right. Can leave it in that rotation file. And if I just bring up GPlates, and I can just drag and drop that rotation file, you can see that it's loaded in the layers window, but the screen is the globe is blank, right? So lots of people get confused by that, right? And that's just because there's no geometries associated with the rotation file. Okay, you need to load in something else. Say, so let's have a look at the, let's dump in the coastlines, and there's Australia. Okay, so what I can do, just to give you an idea of how it's done, I can edit this rotation file. Okay, so if I go to 801 Australia, and we do try to sort them kind of in ascending order. Whoops, just bear with me for a sec. So get rid of word wrap. Where are those 801s? Up in here somewhere. Okay. Okay, this is the Paleozoic portion. Let me go to, oh my God, 801 space 0. Okay, no, there we go. Okay, so there's Australia relative to Antarctica. What I can do, as I mentioned, is I can just comment out a whole bunch of these lines. I can just do 999. I can save. Okay, and remember that in GPlates, I have to go to Manage Feature Collections and reload that rotation. Okay, so you can see that it's already changed things a little bit, because it's interpolating currently from 0 million years ago to this rotation that existed 43 million years ago, and it's ignoring all of these intervening rotations. So say at 10 million years ago, I can say, okay, I don't think this is the correct position. Of course, you'd have other constraints like the magnetic picks and so on. But I can select one of these geometries belonging to Australia, even one of these islands. Okay, there's plate ID 801. I can click on modify the reconstruction pole. Okay, that's this. And one of the great tricks I recommend that you use is this highlight children tool, and that just highlights everything that hangs off Australia in that plate motion hierarchy. Okay, so I can do something like this. I can just move things around. I click by clicking and dragging. If I wanted to rotate, I can press and hold Shift. Okay, so I can do something crazy like that and click Apply and OK. All right. So GPlates will do some crazy stuff for me. It will interpolate between 0 and 10 million years ago, and then it will interpolate deeper in time between 10 and 43 million years ago. Okay, and again, if I go to that Manage Feature Collection, you can see it's made some change. Click Save, and if I reopen this rotation file, there should be an entry at 10. Yep, so it's inserted an entry at 10, and it doesn't actually say that it's done interactively, but you can see what it's done. So Mohammed asks, during the interactive update, can you control the oiler pole or make it not change? Yeah, so that's a good question. In the sense like, okay, as you're moving something around, you want to be able to, fix the position of the oiler pole, the pole of rotation, just be able to do that. You actually can't do that, which is, I agree, would be very useful. But you can do it in, I think, in the PaleoMag option. Okay. So yeah, there are some specific PaleoMag options. We can have a look at that later. And Chris asks, does 909 have to replace the plate identification number, or is it just an indicator that follows the string to be ignored? Yeah, Chris, that's also a good question here. So essentially what you're asking is, can you do that? Technically, what GPlates will expect is that it actually replaces that plate ID. Okay, so just be careful in that you remember what plate IDs you were dealing with, because what it does is GPlate still reads these lines, but it just ignores them. We can experiment with that. Let's do that here. Let's experiment. Great little experiment, Chris. Thank you for that. Okay. So it's not happy about that. I'm curious. So we have a rotation at 0 MA, that's good. And then, yeah, it doesn't seem to like that at all. So let me change that. Reload. No, it doesn't like that. I have no idea what I've done here. So Nicky, yeah, that's an interesting comment. So you can put, you said you can just put an exclamation mark at the front, at the beginning. Nicky, do you want to jump in if you're around?
Yeah, so I found that if you still have the 801 plate IDs, I think you can just put an exclamation mark and it will just ignore it, because the exclamation mark's the comment symbol. So
Oh yeah,
everything after the exclamation mark is a comment. So you can see for the 801 lines, we've got odds and Australia. That's our abbreviations to Australia and Tiger. And so that should work. I just quickly tried it and GPlates didn't complain at me.
Yeah, brilliant. That's a great trick, Nicky.
Yeah, but don't have blank lines in the plate rotation file, because from memory GPlates will complain about. Like, just don't have an empty line with nothing on it, because GPlates doesn't like that from memory. Yeah,
that's another great tip. Oh yeah, and so there's so it's working again. So let's test what Nicky has mentioned here. So let's just put an exclamation mark. So it comes up with an error here. Error reading the moving plate ID. So that's interesting. The other thing that I haven't tested in a while, Nicky's aware of this as well. We have, so the ROT format is an old inherited format from the plates program from Texas. It's a great format, but it was extended to this GROT format. I guess you could say GROT format, but it's meant to, you should be able to use the comments. I'm curious if that will.
I will say because it has an error, it just if you open it up, it says it just discards the plate ID, so it will ignore it essentially.
Okay, so you'll just get an error. That's okay.
Yeah.
So I'm curious now.
It's worked for me, but it's probably not the best way to do it.
Yeah. But now if I just change the extension to GROT, I wonder if GPlates becomes a little bit more forgiving with the yeah, so it seems to be happier with just a comment at the beginning if you use the grot format, which is essentially the same thing, but it seems to be a little bit more forgiving. Yeah, just, you know, this is all for the power users out there. But yeah, and as Nicky said, if I just put that exclamation mark at the beginning, let's see what happens. Okay, so it seems to be more forgiving as well when you do the grot format. Okay. All right, now I did want to, at this stage, let's just fix that, make sure it's working. So it looks like it's fairly sensitive to the sequence of rotations. So that should fix that jump. No, not sure why it's jumping from what have I done? So it jumps from at 43 to 0. It shouldn't do that because there's a rotation here. Anyway, I can investigate that. Okay, now one thing I wanted to highlight is, you can actually load in multiple rotation files that you can activate very easily and compare. Okay, and that can be really useful in testing. Okay, the one thing I will note here is if you load in different plate reconstructions that have, say, topologies, I'll talk about the topologies later, but each topology is very sensitive to what we call these feature IDs. This is a unique fingerprint for each single geometry in GPlates. And if you have, if you've loaded multiple similar plate motion models that might have similar feature ID or the same feature IDs in there, it could really mess things up. So just keep that in mind. Yep, so Zongying asks, how to create a new plate? And I think that's a really common question and something that we should actually talk about. I think that's a really important question. So let's do that. So I love the South China Sea. I'm looking at the Proto South China Sea. So let's have a look here. We have, say China 602, and maybe I want to put in a new volcanic arc, interoceanic arc in here. And so the first thing I do, I'll work with my little test rotation file. So actually, let me just bin these, and I'll just copy and paste. Oops. Keep both, and I'll rename. And just, yep. Okay, great. Okay, the first thing that I recommend if you want to put in a new plate tectonic element is that you should put in some lines in the rotation file. Okay, and really 2 lines are needed. You need to find a spare plate ID. So you can get, if you don't want to muck around and look for, spare 3-digit plate ID. So you can say, okay, what if I want like a plate ID of 602, I don't know, 602, and there's nothing in there. So that's good. So we can use that in here. We can put that anywhere in the rotation file. I mean, you can try to be a bit more organized than I am. Okay, and you put in this 0 MA line. So that's very important. Okay, so that's 0 MA. That's a pole of rotation and the angle of rotation. And 0 MA is nothing, it's 0. Okay, and then the relative plate ID in this case, I just want to have it as South China 602. And then I can just copy and paste that line down here. And I can say, well, I'm only really interested in the last 100 million years. So I put that line in here. Okay, so I just change the age. We can leave these as 0. So you want to save that, load it in GPlates, and again, nothing really happens. And so say I can digitize, or I can import any geometries, but say I want to digitize a polygon. I activate the digitization tool. I can say, well, I reckon some of these things here were a volcanic arc that have shifted from present day to the past. So I create a feature. I can select what it is, but unclassified feature is fine. And so this is the place where you give it that plate ID that you've just created, 602, 602. Make sure that its disappearance is sometimes in the past, distant past. Okay, click next, next. And you can add it to an existing geometry layer or create a new one. So I'll just create a new one. So if I click on it, you can see it has a plate ID. And if I go to say 60 million years ago, you can see it still preserves that relative position at the present day. What I can do, I can say, well, at 60 million years ago, I think maybe that volcanic arc was here somewhere. I can, move it around, click and drag, and as I mentioned before, you can shift, click and drag, and that will, rotate it. So let's just do that. Click apply and click OK. And you'll see that GPlates will then interpolate a motion between, whatever it was, 60 to present. And you can then, step in at any other time and fine tune that position however you want. Okay. And when you save it, when you save those changes, you can see GPlates has inserted those rotations. Okay. One thing you can do is just copy that finite rotation to the final line, save, reload, and if you go back to 100 million years ago, it'll evolve nicely, so there'll be no movement until, what was it, 60 million years ago. So let's just watch that a little bit. Okay, and at this stage we can anchor the South China plate ID, so 602. I can click OK, and we can then isolate, what's happening here. You can then fine tune any of those rotations, move those things around. Okay, so Zongying, I think this is one of the most commonly asked questions that I get, particularly because, okay, we have these plate reconstructions that we provide, and okay, you can modify some of these tectonic elements, but you might want to add your own, split up, some of these terrains and add in extra motions, and that's how you do it. And I thank you for asking that, because I think that's one of the more useful things to learn. So Yudo asks, and one can digitize a new plate in GIS first and import to GPlates, right? Yeah, so Yudo, that's also a really good question. You can absolutely say, start with a static polygons shapefile, which we provide, or you might have your own terrain files or coastlines, and you can digitize things in GIS. There's not a problem. Keep in mind that I recommend that you start with one of the GPlates files that we provide, because there's a whole bunch of other columns in there, the begin age, the to age, the plate ID, and there is this thing, the feature ID. In the ideal world, each feature should have its own unique feature ID, which is automatically assigned to any new features by GPlates. Sometimes, okay, this is kind of like a pro tip. What I do if I'm dealing with ArcGIS or QGIS, and I'm splitting terrains, in GIS, you split the terrain and both features inherit the metadata feature attributes of the original. And that's all fine, except for that feature ID column. What you can do, and what I tend to do, is I actually just clear that column, the feature ID column, just clear it, okay? And then when you load it in GPlates will just automatically assign new feature IDs. Okay, so hopefully that just helps you, understand some of those under the hood things that happen. Okay, and as I mentioned, I do recommend that you work on copies of your files so that you can experiment, you can muck around with it, you can break things, and you can easily recover files. Another tip, many of these things like OneDrive and Dropbox these days, they preserve older versions of files. So if you have a project, you could use that, and then of course the people who are doing this very carefully might use GitHub or Git to version control any changes. Okay, so hopefully that gives you an idea of the rotation, how the rotations are implemented, how you can deal with geometries, and add in your own changes. Are there any questions on some of this?
There's a couple of somewhat unrelated questions, but
Okay.
So Jared asked me, will GPlates support geospatial data from OGC geo packages instead of shape files?
OGC geo packages. So is that I don't know if Jared, if you're around, but I wonder what kind of format. So is it a geo? So
it's a .gpkg.
Yep.
Yeah, that one. Yeah.
Yep, I have never seen a file like that before, but it looks like it's supported. So for those of you who work with lots of different file types, GPlates uses a tool called Gdal. So the Gdal will translate different geospatial data files. So it can translate between GMT and the geo package and all these other things, and it does the same thing with the rasters, and I think it also helps reproject the data. So GPlates uses that Gdal engine to do that, so it's really quite cool and powerful. Okay. Yeah.
Oh, sorry. There was one. I think Mohammed just asked a question, but he had one from earlier.
Yes.
He had a question from yesterday. He said, I geo-referenced a JPEG magnetic data map on ArcMap.
Mm-hmm.
When imported to GPlates, its colors were distorted, and
Right.
I could not get the same colors. Is
Right.
that something you know about?
Great. So we'll talk about the rasters in a little bit. I just want to move on to the kinematics tool, and then we'll jump onto the raster. So keep that
Yes.
question at the back of your mind there, Jono. Thank you for reminding me. Any other questions I've missed? I'm sorry. I tried to keep it up to date with the chat.
That's all for me. Mohammed just asked what the exclamation mark at the end of the line is.
Excellent. So this is an excellent question. Everything after this exclamation mark is essentially ignored by GPlates in terms of the Euler rotation. So you can put in any comment here, any notes to yourself, any references or citations or DOIs where you got this. You can say Sabin's crazy model of volcanic arc. You can save that, and it's preserved. It just helps essentially put in a little bit of documentation or description of what's happening. Okay, if I scroll through the rotation file, you'll see, for example, this is the reference, and we can actually store the DOI so that if you're working on this particular region, it also helps you say, okay, well, we've modified the regional reconstructions of Liu et al. 2017, and you can properly attribute it, right? Because, okay, so one of the things that people do often in literature is they say, well, you know, we use the GPlates plate model and we modified it, right? Now, the thing is, there are many GPlates plate reconstructions. So what I definitely recommend that you do is you know, look at the, you know, the readmes that we provide, and in there we have the relevant citation. So there's Jono here in one of the papers. Okay, so that just helps, you know, because for example, you know, Chris Scotese or Dave and Hinsbergen and others, you know, they've put in all this hard work, and Matt Domeyer, Trond Torsvik, you know, all these people, they put in a lot of hard work. We just want to make sure that everybody in the community is appropriately attributed. Peter asked, is there documentation somewhere that lists the plate IDs and what they refer to? Yeah, so Peter, that's very good. You know, it's particularly good material for any trivia. You know, someone might ask you one day, you know, what's the plate ID of Australia? We did have this somewhere. My God, I remember creating an Excel spreadsheet in PDF. I'm very curious where it's gone. Plate ID PDF. God, I think it's probably dropped out somewhere. So these are some of the old ones. Yeah, so it's in one of the tutorials, but yes, you're right. We should bundle that into the sample data as well. So you can see there's the plate ID, and you know what it, you know, represents. Now keep in mind that different plate reconstructions, as I mentioned, might have a different plate ID. We've tried to stay consistent, but you know, essentially 5 years ago or so, we ran out of 3-digit plate IDs, and so we had to, you know, code in the ability to read in, you know, longer plate IDs to accommodate all these smaller terrains and things. So, Jono, maybe if you can take a note of that, and we can action that and make sure that it's included in the geodata in the future.
Sure thing.
Great. Okay. Any other questions at this point? Oh. Okay. Let's look at interrogating these models a little bit, you know, interactively, in terms of, you know, what are the velocities, you know, and what's implied. So if I, so I'm going to do something a little bit cheeky here. I'm going to go to, say, 50 million years ago, and I'm going to put quite a dramatic motion of this arc. Okay, so I've just interactively edited that. Maybe it's not that dramatic, but anyway, let's see. Okay, so what I can do is in the utilities, I can click on this Open Kinematics tool. Okay, and this is a really powerful little tool. I recommend it. You know, if you're going to use this in teaching, this is the tool to use. It's quite fun and easy to use. So you can put in lots of things manually. You know, you know, a particular point, or you can say use focused feature, and I think it just uses the centroid or one of the points in the center. Okay, it reads the plate ID. You can manually put in the plate ID, and it detects the anchored plate ID that you've set. Let's narrow this analysis to from 60 million years ago to the present in steps of 1. Okay, 1 million years. If I click on update, it will update a lot of the analysis that happens here. So first of all, the first one is latitude. It's very difficult to read by default. And so you can click this magic little button that auto scales the y-axis. Okay, so it just says, it tells you, okay, from 60 million years ago, it's gone south with respect to 602. Now, if we change that to the, spin axis, the absolute positions, click on update, and it will give you some new data. Okay, the same thing with, longitude, the velocity magnitude, so speed in centimeters a year. Okay, one of the things that I really do want to point out here is that you've set here the step of 1 million years. So Karen, I'm gonna go through this again with another example in a moment. But yeah, thanks for reminding me to go over it. One thing that I always recommend is that you click on this settings button, and hard coded in somewhat, or hidden there, is that the velocity time stepping is calculated in 5 million years. So you get a bit of smoothing. So I tend to change this back to 1 million years. Apply and close, and then we can update, and you can see what happens. Okay, as Nicky always says, these step graphs are far more meaningful sometimes. So what I can do is say at 50 million years ago, again, I can be a bit cheeky, and I do something a little bit extreme. Modify that position. I can update, and you can see a whole bunch of these things turn yellow, and it's just highlighting that perhaps something that I've put in there, your speeds are exceeding 20 centimeters a year. Okay, so it's just kind of telling you, like, oh well, maybe have a think about, do you really need those very high velocities? Because on a snapshot, on a figure, that might not be a problem. It's hard to gauge. But when you actually look at the evolution of this stuff, it might be a bit extreme. So let's do something even more fun. Let's make this little arc speed along. Okay, if I click update, you can see that the velocity now is something like 56 centimeters a year. Okay, so it's highlighted as red. Yeah, it just gives you an option to interrogate what's happening. So Karen, let's have a look at India, because India is quite an interesting case with kinematics. So I can select India. Okay, so I can use the selection tool and highlight India. Okay, so hopefully some of you can follow along. So highlight India, go to Utilities, open Kinematics tool, say use focused feature, and it will, figure out some kind of centroid, I believe. It will detect the plate ID, and it will look at the anchored plate of 0. Let's go back to 17 million years to the present and 1 million tools. Click update. Okay, and so here you have, an interesting analysis of, okay, what India is doing. You can see that, India is this essentially the fastest moving known kind of plate that's well constrained, and at least in the Cenozoic. And so it moves about 16 centimeters a year for a period of time. Lots of people talk about that as the arrival of the reunion plume and the lubrication beneath the lithosphere, as well as some potentially 2 northward dipping subduction zones to the north, and so you get this very fast motion of India. Okay, so you can have a look at that. You can instead, if you're interested to just look at the relative motion between India and Eurasia, one of these tectonic elements, you can just say 301, which is Baltica, stable Baltica. So if I type in 301, I press enter, update, and that gives you the relative plate velocities. Okay. If you want to look at roughly, the seafloor spreading history, you can go 501 relative to 802, which is Antarctica, and you might, have a look at the velocity magnitude. So the seafloor spreading rates that you get roughly, okay? And the azimuths as well through time. Keep in mind that an azimuth of 18 degrees is actually quite similar to the azimuth of 345 degrees. It's northward, right? So just keep that in mind. The cool thing about this little tool is that you can then just click on this export table button. So if I click on that, export table, and where is my little GPlates folder? Okay, I can just say India, CSV, and I can go back to this. Okay, so I can open that in Excel or Google Sheets or whatever, and it gives you, everything, the motion path of that point, where you can use, you can let it automatically choose it, or you can specify a point. So you've got the motion path, the speed in centimeters a year, the azimuth, and the angular velocities. Okay, so that can be quite useful for interrogating, the velocities very easily. Yeah, I've seen, school kids quite enjoy, looking at the differences of speeds of different continents through time. Any questions on this? No. Okay. Wenrong asks if we want to plot plate A versus plate B in kinematics, we need to put in plate A, plate ID, and B is the anchored plate. That's correct. Yes. And the velocity azimuth is, for plate A would be relative to that anchored plate. Yep, exactly. So GPlates would essentially assume that that anchored plate will stay in that, present day position, and the motion is relative to that. So, and you can visualize that, say, okay, reconstruction, specified anchored plate 802 would be, say, Antarctica, and it would report back the motion of India with respect to that fixed Antarctica. Peter asks a good question as well. Is it possible to specify and plot non-centroid points on a given plate? Yep, absolutely. So, you might have a fossil, you can select the fossil, you can drop your own point, or, you might have your own favorite points. So I remember in my honors thesis, let's see, kinematics tool, I was using latitude of 30 and 80 east to look at the convergence between India and Eurasia. Okay, so I remember this latitude, this coordinate, right? If you don't want to muck around with that, what you can do is you can essentially digitize a point, okay, and create the feature. Oops, and of course, I should have specified the plate ID, sorry. So activate the digitization tool, select this point tool, drop a point, create feature, click next, give it the plate ID of, say, 501 in this case, which is India. Okay, and again, in that utilities, open kinematics tool, use focused feature, and it will read that easily. Okay, so hopefully that helps make use of that kinematics tool. I think we should have a 5-minute break, after which we can come back and talk a little bit about motion paths, because they're kind of an extension of these things, and then we'll talk about rasters. Okay, so let's take a 5-minute break, and yeah, I'll see you soon. Okay. How is everyone going? Everyone's asleep? There's Marissa. Hey, Marissa. Hey, Jacqueline. Jared, how are you? And Bear's there. I was just checking my very sluggish mantle convection model that I've got here in the lava lab. For some reason, after long periods of time, they lose a bit of their magic. It's very sad. Hey, Marissa, have you got some fossils there to show us? Give us some.
Hey, what do I got? Yeah, I've got some Emu Bay trilobites. I don't know if you can see some Estangia bilobata there.
Yeah.
Yeah.
Well, that's fun.
Plenty of other
We
things.
can put those on GPlates. You know, one of the days in the future.
Yeah, that's right. I'm taking all the notes, Sabin. And I'm sure I'll be rewatching these days again and again.
Yeah, look, I mean, the tutorials might help as well. I'm here to help. You know, drop me a line, any of you, if you get stuck. I mean, there's a huge community that can help. I think in the future, what I might do is every so often organize like an hour, like a Q&A. You know, if people get stuck, just because sometimes it's just so, oh my God, you know, you end up with all of these emails, you bounce back and forth, and you know, it's like, how by the time I explain which buttons to click, you know, it's just easier sometimes to.
Yeah. GPlates agony aunt. You need a little column.
Yeah. Yeah, cool. All right, great. Excellent. Okay, so let's get back into it. There was a question from Yudu about you know, which time stepping to use in the kinematics tool. It's a good question, right? I use 1 million years just because, again, you've got this complex inherited hierarchy where, you know, the African plate has changed its motion, and that has knocked on the effects onto the Eurasia and so on. So I tried to do the 1 million years. It doesn't mean that we have a true 1 million year resolution in the model. So, you know, we have to be very careful with that. One of the reasons why so far we haven't put in extremely high resolutions in the seafloor spreading histories is that you can introduce noise or, you know, velocity artifacts in doing that. And there was a lot of great work done by, I think, Ifaldano and team looking at Redback and looking at minimizing that noise and looking at, you know, reasonable torques acting on plates. So there are people tackling that temporal resolution challenge. Okay, so let's just have a look at, so let's just look at our geodata. Okay, so if I go to GPlates 2.3, and if I go to geodata, let's load in that data bundle for novice, that project file. Okay, and just load that in. I can discard any changes. I don't mind. Okay, so it'll take a moment to load up. One of the things, just I wanted to very quickly talk before we actually look at the rasters is motion paths and flow lines, just very briefly. Okay, so a lot of people do lots of amazing research on, you know, hotspot tracks and so on. There's different models. I mean, Nicky here is the expert on this, and she can jump in. But, you know, one of the things that you might want to be able to do, we looked at this motion path of, say, some random point. So I can click and create a point. I can click on create feature, and up here, if I go to motion path, okay, and click next. Plate ID, well, sure, 501 relative to 301. Okay, and I can create a motion path that's much more visual there. The trick in these motion paths is that you need to actually add this thing called times. So I can click on, highlight it, and click on add. And here I can say, okay, from let's just say 100 to 0, let's just say in 5 million intervals. I click on insert and click OK. I can proceed with next and create. So you don't need to follow along here, but I do just want to highlight that it's possible to do some of this. Let me see if we can make it a little bit simpler. There's this motion path now, and let me just activate the coastline. See, they are. Okay. And you can see that motion path that's being created. Okay. You can export that motion path through time as well, and you can do, you know, interesting things with that. Now, going back to the hotspots, this is, you know, a little bit not more tricky, but just you need to do something similar. So hopefully some of you can follow along. So if we can activate the digitize tool and this point digitize tool, if you've got some existing items here, you can actually clear geometry. Okay, so you can just reset it. And let's just say we want to look at Hawaii. Okay, now if we click on create feature, we can say motion path, that's all good. But we actually want to look at the plate ID. So the plate ID in this case will actually be the mantle, the lower mantle. Now, Nicky, if you're there, what was the plate ID you mentioned? Was it 002 or 003?
It's not in the plate. It's not in the plate rotation file.
It's not in the. Okay. Well,
Yeah.
let's. Okay. Well, let's just say it's 0. Let's just say it's 0, and then 901 is the Pacific plate, and times. Let's just edit. Yeah, that's fine. Remove all from 100 to 0 in 1 million intervals. Yeah, that's fine. Click OK. Next. And create. Okay. So you kind of see what the inferred path is implied by this, the reference frame that's used here. Okay. And you can see that it diverges. The whole Hawaiian thing is fairly complicated, right? Because it doesn't seem to be just a change in the plate motion, but likely a motion of the plume conduit itself. We're not going to dwell on it, but that just gives you an idea how you can create these motion paths. And then what I love also looking at, I mean, I've never really used it in research. I'm sure lots of people have, but you can do something similar with flow lines, and that just kind of creates these synthetic fracture zone geometries. So let me see. So we're dealing with 201 and 701. That's the 2 plate IDs. So I can drop a point, create a feature, and go up to flow line. Next, left plate 201, right plate 701. And again, we have to add those times or edit them. So you can, yeah, that's fine. 100 to 0 in 1 million tools. That's cool. That's fine. Okay. And so that, you know, essentially highlights, you know, that change in seafloor spreading, and it can be really helpful if you've got fracture zones that you're, you know, to check that your models are staying true to these fracture zones. And I'm sure it gets more complicated than this, but that could be useful. Peter asks about the motion paths and exporting the motion paths. That is a good question. So let's jump in. Reconstruction export. I don't know, let's say 50 to 0 in 10 million year intervals. Add export motion paths, and there's different options, but I'm not sure that it exports the polar coordinates. I think it's just the coordinates through time. So I'll just show you what you can expect to see. Open. Okay, so there's an example of that motion path. Well, there's probably two motion paths included there. One for the India-Eurasia and one for the Pacific. And so, yeah, the third column is time, and it's just the latitude and longitude of that through time. I'm not sure if that helps, Peter. Okay, cool. Let's jump into rasters. In the data bundle for novice, you see that you've got topography already linked and moving with the plate reconstructions, okay? And you don't always have that. You might have your own raster. You might want to put a picture of your cat or dog and you know, reconstruct that to Pangea. That's always fun. You know, export that and print it on a t-shirt or something. You know, it's great presents you can make with GPlates. But we'll go through essentially the steps of importing different rasters, and there's different ways of doing it. So the easiest way is if you have, say, a rectangular JPEG or PNG that has global coverage, and that you know that it covers from -180 to 180, -92 to 100. So that's one easy way. The other easy way is if you load in a raster, a color raster or a numerical raster, let's say a GeoTIFF or an IMG file, and GPlates will know exactly where in the world it should put it. And that also includes NetCDF files. I know lots of people use NetCDF files. Okay, so let's go through that example. So let's for those of you who haven't got it up yet, load up that data bundle for novice. And again, if we go to applications, GPlates 2.3, geodata, data bundle for novice, and drop in that project file. Okay. So that will take a minute. And this is why I drink so much coffee, because, like, you know, after a click, you have to wait a minute. Best thing to do is have a coffee. Okay, great. So we've got topography in there. Okay, and it moves. But let's deactivate it. Let's just hide it, and let's put in another raster, which I've provided to you in this kind of short course data folder, wherever that is. Short course data. I'll just unzip that. Okay, and yesterday we imported vector data, you know, your points and so on. Today we'll look at importing rasters. So here is a very easy raster. This is from, I believe this is a UNESCO geological map of the world. And so we can import it. The well, it's somewhat annoying thing, but you know, it is what it is. I can't just click and drag that onto the globe. There's a few steps of importing that. It's very easy though. So I can go to GPlates, File, Import, and Import Raster. Okay. I can specify this file. It's a portable network graphics file. It'll happily take in. I've never seen these ER mapper files. It'll even take a GIF. Is it GIF or GIF? I don't know. We should do a Zoom poll if it's GIF or GIF. JPEGs, NetCDF, PNG, and TIFF, and so on. Okay, but here's a PNG, and GPlates will ask you what band. Most of the time it's just one band. I've never really had to change that. I can click on continue. And this is where, you know, if you've got a rectangular image, well, if it's global, then just leave it as it is. And if it's a region, then hopefully, you know, the bottom, top, left and right longitude extents. There are some more advanced options to use these affine transform parameters. I don't find them that useful because I just use I georeference and rectify these maps in QGIS or ArcGIS, and then I just bring them in as an IMG or GeoTIFF into GPlates. But this option is there for you. So if I click on continue and done, the beautiful UNESCO globe is loaded. Okay. However, if I reconstruct, nothing happens, right? So GPlates doesn't yet know what you want to do with that. And again, we can just go to that layers window. If I scroll down, you can see that, okay, there's the global geology. And we can expand that layer. And we can connect polygons to this. And this is really cool because you can connect any sort of polygon to it. And the simplest one is, for example, the static plate polygons. Okay, so if I go to some time, it will connect those static polygons. Okay, if you're not interested in that, you can say, okay, I just want to look at the continental polygons. I'm just interested in the continental geology. You can do that as well, or you can connect it to the coastlines only, or you know, you can digitize. You can say, well, if you're very accurate with your digitization, or you can digitize a polygon in QGIS, or well, you can do it in GPlates. So if I digitize some kind of blob here, make sure it's a polygon, create the feature, plate ID of 801, sure, 801, love Australia. And I'll show you what happens. I can connect to that polygon and reconstruct through time. Okay. Now, I'll show you some cool things. You can see how quickly GPlates reconstructs that. Part of the reason it's very quick is that when you import the raster, GPlates creates these two cache files, and you can see that they can be quite large. So if you have lots of rasters, keep in mind that these cache files can be large, and these are cache files that are used by the GPU, the graphics card on your computer, to make it really efficient. The cool thing here is that what I can do is I can eject the raster. I can even delete these cache files. Okay, so I can just get rid of them. And next time you want to load in this raster, it's conveniently created a GPML file. So I can just click and drag that GPML file now. It creates these cache files and loads in the raster. So that's quite cool. And again, just to demonstrate, I can expand that layer and connect up polygons. In this case, the static polygons. All right. The really cool thing about all of this is I can now also change the anchored plate. So some of you might be interested in Antarctica, so keeping Antarctica as your reference frame. You can now export this raster for use in GIS to make figures and maps and so on. So you can go to reconstruction, export, and say, okay, well, I just want to look at one time step. Oh no, we want to highlight GPlates functionality, 60 to 0 in 10 million years, 10 million intervals. click on Add Export. And here we can choose, we're dealing with color rasters at the moment. We can export JPEGs, that can be useful, but most of you are probably dealing with some kind of GIS, so you can export GeoTIFFs or IMGs. So let's look at GeoTIFFs, click OK, and click on Begin Export. And there's the color raster, and I should be able to just very easily import that into QGIS or ArcGIS, and that can make life very easy for anyone making figures. Okay, and there it is in all of its reconstructed glory. Okay, now there was a question before about colors, and the colors being messed up in in rasters that you might georeference an image from a paper in QGIS or ArcGIS and export it to say an IMG file. And I've found in the past that yes, the colors can get distorted a little bit, but I've never really had dramatic failures that the colors change dramatically. So you might want to try different raster files, so a GeoTIFF or an IMG file. Hopefully that will fix the color issues, but you can see that GPlates is generally well dealing with the RGB colors in this. Okay, does that make some sense so far? Esan asks, can GPlates be linked to Google Earth? I don't believe that we can export, say, the KMLs or KMZ files. I forget if Google Earth will read in like GeoTIFFs and so on. What I've done in the past is like you export something from GPlates and you bring it into QGIS or ArcGIS. And then from there, you can make KMZ, KML files. I know that it is, John has looked into it in the past, so it might be something that could happen in the future. Peter asks, the color space. I'm not sure if GPlates just exports the color space that kind of comes in with a PNG or JPEG, or if it just forces it into an like an RGB color model. I don't know. I've never had to look at that, but I don't know. Does anyone here have some clues, ideas? Sounds like an experiment for you, Peter. Okay. Fun, yes. And Marissa asks, how does GPlates know how to partition the raster you imported? Excellent question, right? So by default, it doesn't really know what the heck you want at all, right? But you have some other geometries loaded, right? If I just hide everything, and we talked about those static polygons before, okay? Those are the static polygons. So when you make that connection here in that layers dialog here, reconstruct polygon, add new connection, and connect it to, say, the static polygons, it knows what it does is it cookie cuts at the present day all those pixels and attaches them to the rotation of those polygons. Okay. And you can very easily disconnect and connect it to other things like continents or coastlines. Okay. All right. So if I show everything. One of the things that people, well, we all complain, it's like, okay, GPlates is fantastic. We don't have yet enough funding to, put in really pretty and wonderful symbology. But, I might want to use this as a figure, and, exporting as a JPEG, as a screenshot is one option, but it's not the best option. And so one option you might want to explore is exporting as scalable vector graphics. Many of you are using Adobe Illustrator or Inkscape or something like that. So you can go to reconstruction, export, okay, say single snapshot, add export type, and then the second option is projected geometries and rasters and 3D scalar fields. Gives you the SVG option. You can increase the resolution. Just make sure you click on constrain aspect ratio. You can get very adventurous and make it very high resolution. Click OK. Specify that target directory, the output. Open and export. Okay, so I'll just go through that again. So it's this option for projected geometries and SVG. Okay. So what will happen is it's created a scalable vector graphic, and I can open that in Illustrator or Inkscape. Again, good to have a coffee or tea to just, sip while you wait. And these things can get quite complex depending on how many layers you've got. So GPlates will attempt to preserve the layering. And wow, I have no idea why that would appear on the edge of the screen. Thank you, Adobe. Oh my God. It's like 1,000 panels. Okay. Okay, so it's here, and you can say, well, I want to choose all the plate boundaries, and I want to make them thick lines. I want to, use this raster layer and change its opacity, and so on. Okay, you can put in symbology, annotations and so on. Okay, I did write a tutorial, a fairly painful tutorial, but you can follow it along, and it'll help you add subduction zone teeth to your subduction zones using the brush tool in Illustrator. Okay, so that's a pretty good way of exporting figures to use. Okay, so the next couple of things I want to demonstrate is, first of all, okay, we can create these snapshots through time that we can stitch together for animation. So I'll go through that, and then I want to talk about numerical rasters. So there was a question yesterday about, like, how can we deal with numerical rasters, and we'll talk about time-dependent rasters and so on. Okay, so there's lots of different flavors of rasters. Are there any questions at this point? Oh, no, looks like most people are okay. Okay, right. So often we want to create, animations or panels of animations. And the first thing is that, okay, GPlates will export the snapshot, but well, it won't actually by default export the age printed on the panel. So to do that, you want to go to View and Configure Text Overlay. Okay, so enable text overlay. I don't really want decimal places after the age, so I can just change that to 0. And I can change the font. Okay, I can make it some large size font so I can see. 48 points, pixels. I can change the position, the horizontal, vertical offset, essentially a distance, and click OK. All right, so you get something like that. You can then go to reconstruction and export. Again, this menu is one of the most powerful menus in GPlates. And here we can say, well, 60 million years to 0 in, well, 1 million intervals. You can do it 10 million intervals. But I just wanted to show you how you can create these frames for animations. Okay, I can click on Add Export. And here, in this case, it's an image or screenshot. Okay, so it's essentially going to capture what you've got in that GPlates window. Again, you have a bunch of options. The PNG option is really cool because it will actually remove the black background here. So it's quite useful for PowerPoint displays. But what I found is that when I create an animation, I use this little tool called FFmpeg. FFmpeg doesn't seem to like PNGs, so it prefers JPEGs. So just a little kind of warning. By default, what GPlates will do is output a file name, say image underscore, and the age. But many things that require, that want to create an animation, they don't care about geological age. They don't know what 60 MA stands for, and they're more interested in the frame number. And I know FFmpeg is very picky about it. It's the frame has to start at 0 and go up in 1, 1 frame, and it has to be padded zeros in front of these things. So GPlates is useful in the sense that you can use that. It's this %u code that you can put in. So image underscore %u. Again, you can increase or decrease that resolution. You can click OK, and you can click on Begin Export. And you can see it's fairly quick, but it can generate hundreds of files. So you want to put that in some folder that you can potentially delete easily. Okay, so this is what it does. It's creating an image every 1 million years, and it has that nice imprint. Yido says use a software called Shotcut on Windows to make movies, and it handles PNGs well. That's I'm going to write this down. That's really good. Yes, there used to be this funny little tool called Sequimago, and that went away. So I use FFmpeg. I do want to just show you the difference between the PNG and JPEG. Okay, and we can create a lovely slide. Okay. Oh no, that didn't actually leave it. I'm getting confused. Why? You used to have that alpha level. Color raster, image screenshot, PNG. Huh. Well, I may be lying. I wonder if it's in here, this color raster option. That's very weird. I definitely remember the transparencies. Yeah, that's that is interesting. So definitely in these color raster exports, which are essentially these map views, you get the transparencies. But I really thought that these exports did it too. Anyway, I'll follow up, see what's changed. It could be the new updates to OpenGL that have been put in. Okay, so I mean the easy thing to do, thankfully in PowerPoint, is one can just set the transparent color. Okay, and then you can have a nice globe. That's a plan B sort of thing. Yeah, so Peter asks, is there a way to numerically specify the size in GPlates before the screenshots are written out? You know, particularly like this aspect ratio that, you know, TVs, you know, if you want to have a nice TV display. You know, Peter, I don't think it is possible. I wonder if there's some something buried in the preferences. So view this as the default network kinematics graph here. So here you can change that. And advanced. No, I don't think so. Maybe Jono, if you can write a note and we can explore. Yeah, good question. Okay, so those are the animations, and I want to talk a little bit about the numerical rasters, which are really cool because, well, they bypass a lot of these issues and they give us a lot of power. Hodgetts just asks, is there global geology in a shapefile format with age attributes? Yeah, so there are UNESCO and USGS shapefiles floating around with the geology. Their age constraints are typically like the, you know, stratigraphic ages. So you would have to turn it into some kind of numerical age for GPlates to read. Okay. All right. So I want to demonstrate numerical rasters now because they're quite cool. So if I go to the geodata that comes with GPlates, so applications, GPlates 2.3, geodata, and then I go into rasters. Okay, so in here I have a whole bunch of different rasters that I've provided, mainly as JPEGs and PNGs, just to control their file size. Again, the developers get mad when I try to squeeze in too many things in here. But if I look at the seafloor age grid, okay, if I go into that folder, there is an NC file, right? This is a netcdf numerical raster. Okay, and we conveniently already provide you with a GPML, so you can drag the GPML. You can actually drag in the whole project. Okay, and it shows up. But let's say you've got your own netcdf file, okay, just on its own, and you want to import it into GPlates. Okay, again, it's the same process. You would go to File, Import raster, point it to that netcdf file or IMG or GeoTIFF or whatever, and click Open. It won't ask you what the region is because it will read the region from that file. Okay, and so you get something like this. And hopefully some of you have managed to do that. Has anyone had any problems doing that? Okay, so I'll just demonstrate again. If you've got a GPML file already, what will happen is you go to File, Import raster, supply that netcdf, and it will say, well, there's already a GPML file. Do you want to use it? You can say no, and it will go through that process again. Ah, yes, and Peter says, yes, rainbow map. No way. Yeah, we don't want to use the rainbow map. And so I'm actually, yeah, so maybe, Jono, again, I'm sorry to do this to you, but if you can write a note, I think we should get rid of rainbow as the default map. So you can put in any GMT color palette yourself. So you can say, you can click on open and age. Do I have I have some newer color palettes that are not age blues. I mean, you can say, oh, you know, shades of blue, whatever, right? So you can import any color palette. You can remap the ranges here very easily, because again, we're dealing with a numerical raster, okay? Or you can just, you know, reset the data minimum, maximum, and so on. There are some built-in color palettes. So I have, this is kind of my preference these days for the age grid. I think it's like I think it's Inferno. I think this is from the Cremary work. So it's a perceptually uniform color palette, and you can you know, muck around with that again. You can remap it. You might want to look at, okay, maybe you're interested in the age, you know, the very young seafloor, and you can mess around with that a bit. Okay. Just like the other age grids, you can connect it to sorry, just like any other rasters, you can connect it to the polygons. In this case, well, I'm just going to demonstrate this. So let's load in the rotation file and the static polygons. Okay, and so again, I can just reconstruct using those static polygons. Okay, the cool thing about GPlates now is that you can export the color rasters, the GeoTIFF, but you can also export the numerical raster in its reconstruction. So whether in GeoTIFF, let's just say GeoTIFF, we love GeoTIFFs, right? Export, and it's super quick. And now when I go to that folder, there's a TIFF file, and you can see that it's exported it in a reconstructed coordinates, and it's preserved the fact that it's a numerical raster, and you can remap that symbology in your GIS here. I always get confused by the QGIS interface because I usually use ArcGIS render type. You know, anyway, you guys can figure it out, but it can be really cool. Again, you can specify anchored plates just like we were doing before, 101 North America if we're interested, and so on. Okay, so lots of power users might be interested in that. Now, the last thing about rasters before we finish up, I want to show you what we call time-dependent rasters. And again, that lives in the GPlates geodata. So if I go to rasters, there is a folder called time-dependent raster sequences. Okay, and there's many of these that I've put up on our EarthBite FTP site. So for example, the seafloor age grid through time. It's too big to bundle with GPlates, so we just provide the present day seafloor age grid, but we do provide also the time evolving, time dependent raster online. The cool thing is that you can just essentially feed it any raster and just end the file name with a dash or underscore followed by the integer age, right? So essentially GPlates will load up the raster sequence, you know, as it encounters that age. The key thing is that all of these rasters have to have the same region and resolution to make that work. So let me just show you how you would bring in your own. Okay, so you have, in this case, a whole bunch of JPEGs, the tomography depth slices. Okay, so I can go to File, Import, and import time-dependent rasters. I can add a whole directory or just individual files. I'll just say add files. And I can then navigate to my geodata. Oops. Clicking the wrong things here. GPlates 2.3, geodata, rasters, time-dependent raster sequence. And well, I can select all of these. Click open. And so it will create those cache files. It can take a while. You know, if you have 1,000 rasters, you know, well, it's going to take a while, and each one of those cache files can be quite large. So keep in mind the footprint on your hard drive. And you can see that it's read the age from the end of the file name. So here it's 12 million years ago. So it has to be a dash or underscore, and then the age dot JPEG or NC or whatever. So click continue. You can specify the region again. These are global. Click done. Okay. And so GPlates will load in that time evolving raster sequence. Okay. And again, you can export this as animations or SVGs or whatever you want. Okay, so I mean, today I think we've covered a lot. We've covered, you know, rotations and kinematics tool, and then we went on to, you know, how to deal with rasters. Tomorrow, what we'll do is we'll talk about topologies, plate topologies, you know, rigid topologies and deforming topologies, and we'll have a bit of an overview of the volume visualization. So that's going to take us about an hour, both of those things. Then Ben and Nicky will take over and give it a little intro to Python, pyGPlates, and so on. But yeah, okay. Has anyone got any questions on any of this right now? Everyone's fairly comfortable with the rasters then? Okay, great. Well, if you've got any questions, I mean, save them for tomorrow. Jono, did I miss any questions from yesterday or today?
Don't think so.
No.
Yeah.
Okay. Excellent. Okay. Beautiful. Well, thanks for your time, team. Hopefully that gives you a little overview of some of these features. And yeah, we'll reconvene tomorrow if you can join us, and I'll circulate the recording, and that way you can catch up with anything as well. Okay. Thanks, everyone. See you all soon.
See you, everyone.